Hello, myself Somo. Today I am teaching about machine learning. Machine learning is basically machine learned from data. Machine learning is classified into two categories: supervised learning and unsupervised learning. In this slide, I saw three examples. The first two examples are supervised learning, and this one is the unsupervised learning. In first example, we can predict the price of the house based on the size. We can predict the whether this is tumor or not based on the tumor size. In this example, machine classified on in own cluster by itself. In this class, I just only talk about the linear regression, which is under the supervised learning. Supervised learning is classified into two categories: linear regression and logistic regression. In the linear regression, we try to fit a curve in our data. So in this case, in this example, I take a very simple example where I take only one variable and I add weightage and bias, and we try to find this weightage and bias value to fit this curve into our data. So to find whether this weight and bias is correct or not, we will use the loss and cost function. In loss function, we try to find the mean square error where we can differentiate between actual and predicted value. And cost function, we are averaging this loss function values. So if we simplify this equation, we take the b value 0 and we put this equation into the j equation, and then we can get j versus w curve, which is almost parabola. And if we make this curve more complex, if we add b value into it, it gives surface plot. In surface plot, we try to go one point to the minima, and we will do this by gradient descent. In gradient descent, you use these two formula to find the weight and bias value. Here this alpha and the slope is there, and if we put this uh, cost function over this equation, then we can get the final equation. So coming to the next, what would be the alpha value? Alpha is called basically learning rate. So if we took the alpha value very small, it's come very slow. So it's a very slow process. If we took the alpha value very high, it cause overshoot and it not able to reach the minimum. So when to stop? Basically from the learning curve we can find out that, so after number of iteration, when the j value becomes saturated, so that time we can stop. In this curve I am comparing alpha value. So if we took the alpha value very high, the saturation become quick, and if we take the alpha value very low, then the saturation takes time. So earlier we discussed about the univariable. Now if there are multiple variable, what would be the case? So it is very similar. We add different weightage to each and every features to find out the suitable curve which fit the all datas. So we use vectorization technique to do that, and each we use the gradient descent technique for find out each and every weightage. Now coming to the feature engineering. So there are a lot of features are there. So find the suitable features, and engineering is good to find accurate result. So suppose if the house length and depth is there, to rather take length and depth separately. If you take the area, it give much good result. So this would be the good fit for the data. Sometimes we use polynomial equation to find the suitable fit of the curve. And third, feature scaling. So feature scaling is basically has very wide range of data. Some have very low, some has very high. So to uniform that, we try to normalize it, and we try to do between +1 to -1, and we divide the highest value in both side, and we can get this +1 to -1 value. And next, I will discuss about the coding. This is the Python code for the linear regression. In this code, I just import the libraries, then give the data in arrays form, then normalize this data. After that, I initiate theta 0, theta 1 value. Theta 0 is basically bias, and theta 1 is basically weightage. And after that, decide the iteration value, write cost function. This formula already discussed earlier. Then write GD algorithm, and this all formula also discussed earlier. Then this is the final theta 1 or theta 0 value. Then print this theta 0 and theta 1 value. After that, write a predict function over here, give example to predict the value. Now this is and here I plot the cost function, and here I plot the regression line. If I run this code, this will generate this kind of the graph. Like this is graph for the cost function, and this one is for the regression line. So I'll attach this code in my description section, and I also attach my notes in my description section. Please check out.